200,000 feet above Texas. A space shuttle cuts through the atmosphere. Inside, 7 astronauts watch the sky turn bright orange through the windows. They've never seen anything so beautiful. One of them grabs a camera to remember this moment. Below, people stop what they're doing. Look up. Point. Something glowing crosses the blue. Then white streaks, dozens of them, breaking apart, scattering across the sky, a meteor shower perhaps. But no. This is the Columbia disaster, the re-entry that burned astronauts alive. January 16th, 2003, Cape Canaveral, Florida, space shuttle. Columbia sits on the launch pad. This is the shuttle that started it all, the first to ever reach space back in 1981. 22 years later, it's about to fly its 28th mission. Inside the cockpit, 7 astronauts strap in. Commander Rick Husband, a mechanical engineer from Texas. He wanted to be an astronaut since he was 4 years old. NASA rejected him the first time he applied. He applied again, and again, and again. On his 4th try, they said yes. Next to him sits pilot Willie McCool, a Navy test pilot, top of his class at Annapolis. Behind them, the mission specialists, Michael Anderson, David Brown, Kalpana Chawla, the first Indian-born woman in space, Laurel Clark, a Navy flight surgeon and mother of an 8-year-old boy, and payload specialist, Ilan Ramon, the first Israeli astronaut in history. Their mission is simple: 16 days in orbit, 80 scientific experiments, study flames in zero gravity, grow protein crystals, watch how spiders spin webs without weight, then come home. 10:39 in the morning. The engines ignite, 3 million pounds of thrust. Columbia lifts off the pad. The shuttle rises through the clouds, punching through the atmosphere. Everything looks perfect. 81 seconds after launch, something happens. A chunk of foam breaks off the external fuel tank. It's the size of a briefcase. About 2 feet long, weighs less than 2 pounds. It tumbles through the air at 500 miles per hour and slams into the left wing. The crew doesn't feel it. Mission control doesn't see it. The foam is gone in an instant. Columbia keeps climbing. 43 minutes later, the shuttle reaches orbit. The mission begins. The next day, engineers review the launch footage. Frame by frame, they spot the foam strike. But the cameras were too far away. The angles are bad. The images are blurry. They can't tell how bad the damage is. This has happened before. Foam has fallen off the tank on previous missions. It's never caused a disaster. NASA calls it foam shedding. It's considered normal, but this time the foam hit the leading edge of the wing. The part covered in reinforced carbon-carbon panels. These panels protect the shuttle from the 3,000-degree heat of re-entry. They're tough against heat, but brittle against impact. If those panels are cracked, superheated air will pour inside during the descent. The shuttle will burn from the inside out. Some engineers suspect the worst. They want answers, but getting them won't be easy. Rodney Rocha is NASA's chief structural engineer. He's been with the agency for decades. He knows these shuttles inside and out. He watches the foam strike footage over and over. Frame by frame, the image is grainy. The foam is just a blur. But his gut tells him something is wrong. He leads a team called the Debris Assessment Team. Their job is to figure out if the damage is serious. But they have a problem. The footage is too blurry. They can't see the wing clearly. They need better images. Rocha has an idea. The military has spy satellites, high-powered cameras that can read a license plate from orbit. They've helped NASA before. Back in the early shuttle days, the Air Force took photos of Columbia's heat shield from space. They can do it again. Rocha sends a request up the chain. Get us pictures of Columbia's wing. 3 days pass. The request goes nowhere. Rocha sends more emails. He calls meetings. He begs for help. In one message, he writes, "Can we petition, beg for outside agency assistance?" He warns of grave hazards and the risk of catastrophic damage during re-entry. His warnings reach Linda Ham. She's the chair of the mission management team, the person in charge of the flight. Every major decision runs through her. Ham doesn't approve the request. Instead, she asks a question. Who's requesting the photos? Not, what's the risk? Not, how can we help? She wants to know who's making noise. The request dies. There's a chain of command at NASA. Engineers report to managers. Managers report to directors. Information flows upward, or it's supposed to, but the system is broken. Concerns get filtered. Warnings get softened. By the time bad news reaches the top, it doesn't sound so bad anymore. Boeing, one of NASA's contractors, runs the numbers using a computer model called Crater. The model is designed for small debris impacts, pebbles, ice chips, not a 2-foot chunk of foam traveling at 500 miles per hour. They use it anyway. The results say the damage is minor, but Crater wasn't built for this. The engineers know it. They put a caveat in their report. The analysis is uncertain. The results may not apply. Management ignores the caveat. They see the bottom line, no safety concern. On January 23rd, day 8 of the mission, NASA sends an email to the crew. They mention the foam strike. They include a short video clip, and they add this line: there is absolutely no concern for entry. The astronauts read the message. They move on. They have experiments to run. 4 days later, the crew holds a moment of silence. It's January 28th, the anniversary of the Challenger disaster. 17 years ago, 7 astronauts died when that shuttle exploded 73 seconds after launch. Commander Rick Husband speaks from orbit. He honors the Challenger crew. He says their sacrifice still inspires people around the world. He has no idea of what's to come. February 1st, 2003. Columbia prepares to come home. The crew wakes early. They eat breakfast. They stow their equipment. They close the payload bay doors and seal the hatches. The mission is complete. 80 experiments finished. More data than scientists expected. Commander Husband and pilot McCool float to the flight deck. They run through the checklist, test the flight controls, check the navigation systems. Everything looks normal. The weather in Florida is perfect, clear skies, light winds. The families are already gathering at Kennedy Space Center, waiting to welcome their loved ones home. At 8:15 in the morning, Eastern Time, Columbia fires its engines. The shuttle slows down by 176 miles per hour, just enough to drop out of orbit. It begins the long fall back to Earth. 1 hour to landing. In Houston, Flight Director Leroy Kane watches from Mission Control. He's been doing this for years, dozens of flights, dozens of safe landings. This morning feels routine. Let's go get 'em, guys, he says to his team. At 8:44, Columbia hits the top of the atmosphere. They call this moment entry interface. The shuttle is 400,000 feet above the Pacific Ocean, traveling at 17,000 miles per hour. Outside, the air begins to glow. Friction heats the atmosphere around the spacecraft. Superheated plasma wraps around Columbia like a cocoon. Temperatures climb past 2,500 degrees. The windows turn bright orange. Inside the cockpit, the crew watches. Kalpana Chawla sits behind the pilots. Laurel Clark holds a camera. She films the glow. They've never seen anything like it. This is normal. The heat shield is designed for this, but there's a hole in the left wing. And right now, 3,000-degree plasma is starting to pour inside. At 8:52, 9 minutes into re-entry, a sensor goes offline, then another, then 4 more, all on the left side. Jeff Kling is the systems officer monitoring the data. He sees the readings vanish from his screen. Tire pressure, tire temperature, hydraulic systems, all gone. He calls it in. Flight Max, we've lost tire pressure on the left main gear. Kane asks for more information. Kling doesn't have any. The sensors are just gone. Capcom, Charlie Hobaugh radios the crew. Columbia, Houston, we see your tire pressure message, and we did not copy your last call. Commander Husband responds. His words are broken, choppy. The signal is failing. Roger, but that's it. That's the last word anyone hears from Columbia. In Mission Control, confusion turns to dread. More sensors drop offline. The data stream flickers, then goes dead. The radar stops tracking. Kane asks when they should expect tracking from Florida. 1 minute ago, comes the answer. Across Texas, 911 lines are exploding. People are calling in strange lights, explosions in the sky, debris falling on highways and rooftops. A loud boom rattles windows in Dallas. Off-duty flight director Brian Austin is outside Houston. He stepped out to watch Columbia pass. Overhead, a streak of light. Then he sees it break apart. He calls mission control. His voice is shaking. Done. I saw it. It broke up. Flight director Phil Engelhoff takes the call. He turns to Kane. Tells him what Austin just said. Kane stares at his screen. The room goes silent. 17 years ago, another flight director sat in this same seat. He watched Challenger explode on a monitor. Now it's happening again. Kane composes himself. He turns to his team. A tear runs down his cheek. Lock the doors. Those 3 words mean it's over. No one leaves. Preserve everything for the investigation. Columbia is gone, but the question remains, what exactly killed them? The debris field stretches across 2,000 square miles of East Texas and Louisiana. Pieces of the shuttle rain down on highways, fields, and backyards. Within hours, search teams fan out. Thousands of people. NASA workers, FBI agents, National Guard troops, local volunteers. They walk grid patterns through forests and swamps. They find twisted metal, burned wiring, shattered tiles. Over the next 3 months, they recover 84,000 pieces, about 38% of Columbia by weight. They also find the crew. All 7 bodies located within a 5-mile radius, identified through DNA. Investigators pieced together what happened, second by second. The foam strike punched a hole in the reinforced carbon panels on the left wing, 6 to 10 inches wide, not big, but big enough. For 16 days, the hole sat there, invisible, waiting. During re-entry, superheated plasma, over 2,700 degrees, poured through the breach. It melted the aluminum structure inside the wing, burned through wiring, destroyed hydraulic lines. At 207,000 feet, the wing failed. Columbia rolled hard to the left. The autopilot fired thrusters to correct. It couldn't keep up. The shuttle tumbled. The spacecraft tore itself apart. The crew module separated from the fuselage at 140,000 feet. Still traveling 10,000 miles per hour, rapid. Depressurization hit instantly. Some astronauts weren't wearing gloves. Some didn't have their visors down. They lost consciousness in seconds. The official cause of death? Blunt trauma and hypoxia. A damaged videotape is recovered from the wreckage. It shows the crew's final minutes on the flight deck, watching the glow of re-entry, smiling, relaxed. The footage ends 11 minutes before they die. In August 2003, the Columbia Accident Investigation Board releases its report. The findings are devastating. NASA's organizational culture had as much to do with this accident as the foam. The board lists 8 missed opportunities, 8 chances to save the crew. Rodney Rocha's unanswered emails, the denied requests for satellite imagery, the flawed computer models, the emails telling the crew not to worry. The investigation reveals something else. If NASA had known about the damage, they might have saved them. The shuttle Atlantis was being prepared for launch. It could have been rushed to orbit for a rescue, or the crew could have attempted a spacewalk repair. Risky, difficult, but possible. None of that happened. Rodney Rocha still works at NASA. He helped get the shuttles flying again. But one regret haunts him. I didn't break the door down.